Boeing's next-generation air dominance NGAD demonstrator, a milestone in military aviation development. Introduction. Boeing's next-generation air dominance NGAD demonstrator has marked a significant advancement in military aviation, transitioning from contract award to first flight in less than 2 years. This rapid development trajectory highlights a shift in the approach to military aircraft production, emphasizing efficiency and production readiness over traditional prototyping methods. This report will detail the key elements of the NGAD demonstrator's development, its implications for future aircraft programs such as the F-47 and F/AXX, and the broader context of military aviation advancements. Rapid development timeline. Boeing's NGAD demonstrator achieved its first flight in a remarkably short period, underscoring a modern military aviation push for expedited development cycles. The contract award initiated a focused and accelerated development phase, enabling Boeing to leverage advanced manufacturing processes that result in significant time savings. This swift transition serves as a template for future projects, particularly the F-47 and F/AXX, for which stakeholders anticipate a rollout within 3 years of initial contract awards. Production readiness. A critical aspect of the NGAD demonstrator and its successors is the emphasis on production readiness. Unlike traditional prototypes, which often incorporate experimental designs and materials not intended for final production, Boeing has adopted a strategy that integrates production methodologies from the outset. The demonstrator was built with rigorous production standards, utilizing the same tooling and manufacturing lines that will be used for the operational fleet. This approach minimizes discrepancies between developmental models and final aircraft, ensuring that early test articles are representative of the capabilities expected in operational units. The B-21 Raider, another advanced military aircraft, serves as a parallel example of this production-oriented philosophy. Similar to the NGAD demonstrator, the B-21 was developed with the intention of creating a seamless transition from testing to operational deployment, reinforcing the notion that modern military aircraft programs are increasingly designed with production efficiency in mind. Historical context. The military aviation industry has historically grappled with lengthy development timelines and the challenges associated with transitioning from prototype to operational aircraft. Traditional practices often resulted in prototypes that were not reflective of final production standards, leading to extended testing phases and operational delays. However, the NGAD demonstrator and its planned successors represent a transformative approach that prioritizes production methodologies and operational readiness from the very beginning of the development cycle. This evolution in military aircraft design and production is not merely a trend but a necessary adaptation to the rapidly changing landscape of global military needs and advancements in technology. As adversaries develop increasingly sophisticated capabilities, the U.S. military's ability to deliver advanced aircraft in a timely manner becomes paramount. Challenges and considerations. While the optimistic timelines for the F-47 and F/AXX are promising, several external factors could influence the development process. Potential protests or delays in congressional appropriations may impact the schedule, introducing uncertainties that could extend timelines beyond initial projections. Despite these challenges, both Boeing and the U.S. Air Force remain dedicated to a production-oriented approach, with the hope that this commitment will mitigate delays and ensure successful program execution. Timeline of events. 1. Contract award. The timeline for the NGAD demonstrator began with the awarding of the contract, which set the stage for an accelerated development phase. 2. First flight. Achieved in under 2 years, the first flight of the NGAD demonstrator illustrates an efficient path from concept to testing. 3. Future projections. Following the successful development of the NGAD demonstrator, the F-47 and F/AXX are expected to enter their respective development phases with a target rollout within 3 years of their contract awards. Common themes across sources. The analysis of multiple sources reveals several consistent themes regarding Boeing's NGAD demonstrator and future aircraft programs. Rapid development. The swift transition from contract award to flight testing is a recurring highlight, signaling a new era in military aircraft development. Production orientation. There is a unified expectation that future aircraft, specifically the F-47 and F/A-XX, will be developed as production representative systems rather than traditional prototypes. Emphasis on manufacturing processes. The focus on rigorous manufacturing processes from early development stages marks a significant shift in military aviation design. Conclusion. Boeing's advancements with the NGAD demonstrators signify a pivotal moment in military aviation characterized by rapid development cycles and an emphasis on production readiness. The implications of these developments extend beyond the immediate projects at hand, potentially reshaping the future landscape of military aircraft programs. As the F-47 and F/A-XX approach their respective development phases, the adherence to production-oriented methodologies will be critical in ensuring timely and effective deployment of next-generation capabilities. The commitment to efficiency and operational readiness within the U.S. military's aircraft development strategy is likely to have lasting impacts on its overall effectiveness and adaptability in an ever-evolving global security environment. Boeing's progress with the next-generation air dominance NGAD demonstrator and the anticipated development of the F-47 and F/A-XX aircraft reveals several counterintuitive insights about the current trajectory of military aviation. Here are the key points that challenge traditional expectations. 1. Speed of development versus historical norms. Historically, military aircraft programs have often experienced lengthy development timelines, typically spanning several years or even decades. The rapid turnaround from contract award to first flight of the NGAD demonstrator in under 2 years is a stark contrast to this norm. This swift development raises questions about the balance between speed and thoroughness in testing and validation. It suggests that, contrary to the idea that thorough testing requires extensive time, new methodologies may enable faster progress without compromising quality. 2. Prototypes versus production readiness. Traditionally, prototypes have been seen as preliminary models that often don't reflect the final product due to ongoing design iterations and modifications. However, both the NGAD demonstrator and the B-21 Raider are being developed with production processes right from the start, which is a significant shift in approach. This challenges the assumption that prototypes must be separate from production models. The expectation that the F-47 and F/A-XX will be developed as highly representative of production aircraft suggests a redefinition of what constitutes a prototype in military aviation. 3. Integration of advanced manufacturing techniques. The integration of advanced manufacturing techniques early in the development cycle is counterintuitive to the historical separation of design and production phases. The fact that initial test articles are being built using the same tooling and standards that will be applied to the full production fleet indicates a transformative approach. This could lead to fewer discrepancies between test aircraft and operational capabilities, contradicting the assumption that different phases of development require different manufacturing processes. 4. Optimism amid potential delays. The optimism surrounding the timelines for the F-47 and F/A-XX, suggesting rollouts within 3 years of contract awards, runs counter to the frequent reality of delays in military contracts due to protests or budgetary constraints. While acknowledging these potential setbacks, the assertion that the commitment to production-oriented development will lead to timely rollouts challenges the conventional wisdom that military projects are inherently prone to delays and overruns. 5. Evolving role of protests in defense contracts. The mention of protests as a potential disruptor raises the question of their actual impact on timelines. Traditionally, protests have been seen as major roadblocks to progress. However, the current discourse around the NGAD and its successors implies a belief that the momentum generated by modern development practices may mitigate the typical delays associated with such challenges. This counters the expectation that protests will invariably slow down the process significantly. 6. Changing dynamics of military procurement. The changing dynamics of military procurement processes. As evidenced by the rapid development of the NGAD Demonstrator and the anticipated F-47 and F/AXX programs suggest a move towards more agile and responsive procurement strategies. This could indicate a shift away from the bureaucratic inertia that has characterized past military procurement, challenging the assumption that such processes are always slow and cumbersome. Conclusion: Boeing's advancements with the NGAD Demonstrator and projections for future aircraft development illustrate a transformative era in military aviation characterized by rapid development timelines, production readiness in prototypes, and the integration of advanced manufacturing processes. These counterintuitive insights challenge long-held beliefs about the pace and nature of military aircraft development, suggesting a shift towards a more efficient and responsive approach that could redefine expectations in the field. The report on Boeing's next-generation air dominance NGAD demonstrator and its implications for future aircraft development. Specifically, the F-47 and F/AXX presents several important points that may be overlooked by many readers. Below is an analysis of these significant aspects and their implications. Rapid development and production readiness. Significance: the speed with which the NGAD demonstrator progressed from contract award to first flight, less than 2 years, is noteworthy. This rapid timeline is not merely about efficiency, it reflects a deliberate strategy to integrate advanced manufacturing processes and production methodologies from the outset of development. 1. Modern military needs. In an era characterized by rapidly evolving threats, the ability to bring advanced capabilities to operational status quickly is essential. The military landscape demands that new systems are fielded faster than ever, making this speed in development crucial for maintaining strategic advantages. 2. Cost efficiency. By utilizing production representative systems early in development, Boeing is likely to reduce costs associated with transitioning from prototype to production. Historically, prototypes often require significant redesigns to meet operational standards, leading to increased costs and delays. The approach taken here could minimize these hurdles. 3. Impact on future programs. The expected trajectory for the F-47 and F/AXX following a similar development pattern signals a broader shift in military aviation design philosophy. This could influence not just Boeing's future projects but also set a precedent for other defense contractors, potentially revolutionizing how military aircraft are developed. Historical context and shift in development philosophy. Significance: the report highlights a significant historical shift in aircraft development. Traditionally, prototypes were often not representative of the final product, which could lead to issues during testing and production. 1. Incorporation of advanced manufacturing. The integration of advanced manufacturing processes at an early stage marks a departure from prior practices. This represents a transformative approach where the developmental phase incorporates the efficiencies and standards of mass production. 2. Long-term implications. If the trend continues, future military aircraft development may see less variability between prototypes and production models, enhancing overall program reliability and predictability. This shift could lead to a more agile military force capable of adapting quickly to new technologies and threats. Challenges and considerations. Significance: although the report maintains an optimistic outlook on the timeline and development strategy, it does not shy away from acknowledging potential challenges such as protests or congressional appropriations. 1. Legislative and political factors. The mention of potential protests highlights the political and bureaucratic challenges that can affect defense contracts, even with a solid plan in place. External factors can significantly disrupt timelines. This underscores the importance of not just technological advancements but also a stable political environment for successful program execution. 2. Risk management. The optimistic projections could be seen as risky if not managed properly. Stakeholders must be aware of these risks and develop contingency plans to mitigate potential delays. Production-oriented development process. Significance: the commitment to a production-oriented development process signals a strategic focus not just on the aircraft's technical capabilities but also on how those capabilities will be manufactured and sustained. 1. Operational readiness. By prioritizing production readiness, Boeing is ensuring that the systems developed will be ready for operational deployment without extensive modifications. This operational mindset can lead to faster integration of new aircraft into the existing fleet, enhancing overall military readiness. 2. Sustainability of military operations. A production-ready mindset not only benefits initial deployment but also extends into maintenance and support. Aircraft that are designed with production principles in mind are often easier to maintain, which can have long-term benefits for military operations and budgets. Parallels with the B-21 Raider. Significance: drawing parallels between the NGAD Demonstrator and the B-21 Raider reinforces the notion of a new standard in military aircraft development. 1. Benchmarking success. The B-21 Raider's development has set a benchmark for what is achievable in terms of timeline and production readiness. By aligning the NGAD and future aircraft programs with the successful strategies employed in the B-21 program, Boeing can leverage lessons learned to enhance its own development efforts. 2. Competitive landscape. As other defense contractors observe these developments, they may be compelled to adopt similar methodologies to remain competitive. This could lead to a broader transformation across the defense industry, fostering innovation and efficiency. Conclusion: Boeing's advancements with the NGAD Demonstrator signify a transformative moment in military aviation development. The emphasis on rapid development, production readiness, and historical shifts in design philosophy are critical elements that could reshape how future military aircraft are conceived and produced. Readers should pay close attention to these aspects as they not only reflect Boeing's strategic direction but also have broader implications for military readiness and defense industry practices. By recognizing these nuances, stakeholders can better understand the trajectory of military aviation and its potential impact on national security. Key points for in-depth analysis and discussion: Boeing's NGAD Demonstrator and future aircraft development. 1. Rapid development timeline. The NGAD Next Generation Air Dominance Demonstrator's successful transition from contract award to first flight in less than 2 years represents a significant shift in military aircraft development. This rapid timeline is indicative of modern defense procurement strategies that prioritize speed and efficiency, reflecting broader trends in technology and project management. Analyzing this point involves understanding the implications of such swift development on operational readiness, cost efficiency, and the potential for future innovations in military aviation. Furthermore, comparing this approach with historical development timelines can shed light on how lessons learned from past projects have shaped current practices. 2. Production readiness and methodology. The assertion that the F-47 and F/A-XX aircraft will be developed as production representative platforms rather than mere prototypes is a critical aspect of Boeing's strategy. This production-oriented mindset suggests a more integrated approach to design and manufacturing, wherein initial test articles leverage the same tooling and processes that will be used in full-scale production. Analyzing this point involves exploring how such methodologies can reduce costs, minimize developmental risks, and enhance the overall lifecycle performance of military aircraft. It also raises questions about the challenges of implementing such practices, including the need for rigorous quality control and the potential impact on the testing and evaluation process. 3. Historical context and shifts in military aviation design. The move toward incorporating production methodologies early in the development phases marks a notable transformation in military aviation. Historically, prototypes often differed significantly from final production models, which could lead to delays and increased costs. This shift reflects a growing recognition of the need for alignment between development and production phases to ensure that military assets meet operational requirements from the outset. A deeper analysis could compare this trend with other industries that have successfully adopted similar practices such as automotive or aerospace commercial sectors and examine how these lessons can be applied to military aviation. 4. Challenges and external factors. Despite the optimistic projections for the rollout of the F-47 and F/AXX, there are inherent challenges and external factors that could impact these timelines, such as potential protests or delays in congressional appropriations. Evaluating this point requires a consideration of the political, economic, and social dimensions that influence defense projects. Analyzing the role of stakeholders, including government entities, contractors, and the public, can provide insight into how external pressures may affect the pace and direction of military aviation development. Furthermore, understanding the implications of such challenges on project management and strategic planning can yield valuable lessons for future programs. In conclusion, Boeing's advancements with the NGAD demonstrator not only signal a new era in military aviation but also present a compelling case for examining the intersection of technology, production methodologies, and external influences in defense development. These key points provide a robust foundation for further analysis and discussion, highlighting the transformative potential of modern approaches to military aircraft design and production. 1. Lockheed Martin's F-22 Raptor development. The F-22 Raptor, known for its stealth capabilities and supercruise performance, underwent a rapid development process from its inception to operational status. The program was initiated in the late 1980s, but the first flight took place in 1997, less than a decade later. The F-22 was designed with advanced manufacturing techniques and included production representative test articles, helping to streamline the transition from prototype to operational aircraft. This expedited timeline and focus on production readiness set a precedent for future military aircraft programs. 2. Northrop Grumman B-2 Spirit. The B-2 Spirit stealth bomber was another significant development in military aviation introduced in the late 20th century. The B-2's design and production phases were characterized by the incorporation of innovative technologies aimed at reducing radar cross-section. Its first flight occurred in 1989, approximately 6 years after the program was launched. The B-2's production strategy involved creating aircraft that were not only prototypes but were also intended for operational deployment, reflecting a shift in how advanced military aircraft were developed and manufactured. 3. Airbus A400M Atlas. Although primarily a military transport aircraft, the development of the Airbus A400M Atlas demonstrates a rapid transition from contract award to first flight. The program faced challenges but ultimately achieved its first flight in 2005, just a few years after the contract was awarded in 2003. The A400M was designed to meet specific operational requirements and included production-ready features from the outset. This approach aimed to minimize the gap between development and operational capability, similar to the expectations surrounding Boeing's NGAD and future aircraft programs. These cases illustrate a trend in military and aerospace development that emphasizes rapid timelines and production readiness, aligning with the strategies seen in Boeing's NGAD project and future aircraft initiatives. Future outlook on Boeing's next-generation air dominance program. As Boeing continues to push the boundaries of military aviation with its next-generation air dominance NGAD program, the future outlook remains optimistic. The rapid pace of development seen with the NGAD demonstrator and the anticipated engineering manufacturing development EMD phases for the F-47 and F/AXX aircraft indicate a significant shift in how military aircraft are designed and produced. Here are key predictions shaping the future of these next-generation aircraft. 1. Accelerated development timelines. The impressive timeline from contract award to the first flight of the NGAD demonstrator, achieved in less than 2 years, sets a new precedent. If Boeing can replicate this efficiency for the F-47 and F/AXX, we could see these aircraft roll out within 3 years of their respective contract awards. This rapid timeline reflects the military's increasing demand for agility and speed in response to evolving threats and geopolitical landscapes. 2. Production representative aircraft. There is an expectation that the F-47 and F/A-XX will not merely be prototypes but will be built with production readiness in mind. Utilizing the same tooling and manufacturing processes from the outset will ensure that initial test articles are representative of the final products. This approach minimizes the risk of costly redesigns and delays that have historically plagued military aviation projects. As seen with the B-21 Raider, this strategy could lead to smoother transitions from development to operational capabilities. 3. Integration of advanced technologies. The NGAD program is poised to integrate cutting-edge technologies such as artificial intelligence, advanced materials, and next-generation avionics. The continued investment in research and development will enable the F-47 and F/A-XX to incorporate advancements that enhance situational awareness, stealth capabilities, and combat effectiveness. The integration of these technologies will likely redefine air combat operations and establish new standards for future military aircraft. 4. Focus on sustainability. In line with global trends, Boeing is expected to consider sustainability in the design and production of the F-47 and F/A-XX. This includes the potential use of sustainable aviation fuels, energy-efficient systems, and reduced environmental impact during manufacturing. As military operations increasingly align with sustainability goals, these considerations will become a critical aspect of future aircraft development. 5. Challenges and risks. While the projections are optimistic, several challenges could impact the timelines and development processes. Potential protests, congressional appropriations, and budget constraints may create unforeseen delays. Furthermore, as with any advanced military program, technological hurdles may arise that could necessitate adjustments to timelines and designs. Boeing and the U.S. Air Force must remain agile in navigating these challenges to meet their projected goals. 6. Geopolitical considerations. The development of the F-47 and F/A-XX will not occur in a vacuum. Geopolitical tensions and emerging threats will influence the urgency and prioritization of these programs. As adversaries continue to advance their own military capabilities, the U.S. will need to ensure that its next-generation aircraft maintain a competitive edge. This may lead to increased funding and support for the NGAD program, further accelerating its development. 7. Collaborative development and testing. Future aircraft development may increasingly rely on collaborative efforts involving partnerships with other defense contractors and international allies. This collaborative approach can enhance innovation, share costs, and expedite the testing processes. The integration of feedback from allied nations could also lead to a more versatile and capable fleet, aligning with broader defense strategies. 8. Evolution of military doctrine. The introduction of the F-47 and F/A-XX will likely prompt a re-evaluation of military doctrine and strategies. As these aircraft bring new capabilities to the battlefield, military planners will need to adapt operational concepts to fully leverage their potential. The emphasis on networked warfare and multi-domain operations will shape how these aircraft are utilized in conjunction with other military assets. Conclusion. The future of Boeing's next-generation air dominance program is marked by ambitious timelines, advanced technologies, and a commitment to production readiness. While challenges lie ahead, the potential for the F-47 and F/A-XX to redefine air superiority is substantial. As the military landscape evolves, these aircraft will play a critical role in maintaining national security and addressing emerging threats. The focus on rapid development, sustainability, and collaborative strategies will shape the trajectory of modern military aviation in the years to come.